Good morning everybody. Today I'll try to discuss about surface unit. The surface unit will have several components. The surface unit will be driving your PCP part. So how does it look like? Like this is surface and your casing is there. Inside casing there will be tubing, and tubing is having your pump. All right, I am hatching it. Okay, this hash section showing pump. Okay, pump will be run by your sucker rod. Okay, then sucker rod will be driven by your motor and drive system. Okay, so motor is here. Motor will be like this. This is 3-phase induction motor, normally 4-pole or 6-pole. Okay, and there will be belt drive. There will be speed reducer. Normally motor speed will be like 3000 rpm, like 50 hertz or 60 hertz. If you take 3600 rpm will be there. So that rpm you are not using because your PCP rpm is, I told, 300, about 300 rpm. Okay, 3 to 500 rpm, but sometimes it will be 100 rpm also based on your wellbore criteria. For example, very thick fluid is there, so you can run with very slow speed, that is okay, but thin fluid normally you have to run at higher speed. Now sucker rod is coming here, and this section will have your polish rod. Okay, so polish rod will be like this. Polish rod will be there. Then one stuffing box. Stuffing box will be there. Then from stuffing box, the polish rod is connected to your main sucker rod. Okay, when you are reducing speed, there will be maybe belt drive. Okay, so belt drive, sometime gear drive also will be connected with this one to reduce the speed actually. So you are not connecting directly your motor to your sucker rod because speed issue is there, so you have to reduce the speed. And belt drive, basic discussion I have done in our sucker rod pumping system. If you see surface unit of sucker rod pump, there I have discussed about belt drive and gear drive, so please go through that portion of sucker rod pump. Now this polish rod, this stuffing box, it is similar to sucker rod pump stuffing box, like seal section. Stuffing box means seal section. Okay, so whatever wellbore fluid you are getting, so wellbore fluid should not cross the seal section, rather it will go through your line. Okay, line means it will go to your separator system. Okay, so this wellbore, whatever wellbore fluid you are producing, if it is crossing the stuffing box, then there will be leakage. Okay, so this way. And left side picture I have seen, you can see this one I have taken from Weatherford catalog. Actually the link is given below. So here you can see the motor. Okay, and there is a drive system, belt, normally belt will be there. Then there will be stuffing box. Okay, stuffing box will be there. Inside there will be polish rod, you cannot see here. Okay, and then T junction is here, so your fluid going to separator. Okay, and your sucker rod, that polish rod, is moving directly to your wellbore. Okay, this is, there will be sucker rod, you cannot see here actually. Sucker rod I already discussed. Sucker rod will get basically torque, but in SRP sucker rod got tensile strength, tensile stress, or tensile load. Okay, now let's go to the next slide. Yeah, so the surface unit is having one variable speed drive, or VSD, or variable frequency drive, or VFD. If you have VFD, then it is actually AC drive and you can use directly to your IM, induction motor. But if you have VSD, then you can connect to AC or DC motor. So normally we are using AC induction motor 3-phase, so we can use any VFD or VSD, and this will be part of surface system, so that you can have more control over your pumping speed. So you want to change 300 to 250 rpm or 300 to 350 rpm of your pump, then you cannot change actually your belt drive or gear system, because those mechanical systems will replace. Rather, you have one VFD or VSD control unit. There you change your frequency or change your parameter, then automatically frequency will be changed, so automatically speed will be changed. So instead of mechanical small change in speed, you can change pump speed using VFD or VSD. So this will be connected to your motor. Okay, so VFD or VSD, it will be connected to a motor. Okay, so motor power will go to your belt drive. Okay, so so that power will go to your polish rod. Then one pony rod will be there. So from pony rod to sucker rod to pump. Okay, you see the sequence of power transmission. Variable frequency drive, it will be connected to main transformer. Okay, it's transformer to VFD to motor to belt drive or drive system, then polish rod, pony rod to sucker rod, polish rod, sucker rod to pump. Finally, you are delivering fluid, and pump is basically positive displacement pump. So very high viscosity fluid can be pumped using progressive cavity pump. Okay, this is PCP or progressive cavity pump. Now I said like belt drive. This picture I have taken from one of my friend is having some husking mill, so they have belt drive. So I took this picture actually. I hope it will run. Yeah, you can see this belt drive. This is the belt drive. Okay, and this is flat belt drive. This one flat belt. This is flat belt drive, and this one is having V belt drive. What is the difference between V belt drive, flat belt drive? V belt drive can it can transfer more power. Okay, more power, and several V belt will be connected, like 5 or 7 belts will be connected, will be there. Okay, and this is called sieve. Okay, so there is a sieve or 2 pulleys, sometimes we say pulley. Okay, so this is sieve, this is belt, this is sieve. Okay, so just I am drawing sieve. Okay, so here what is the purpose? There is motor actually. This small pulley is connected to motor. Big pulley is connected to your sucker rod. Why big pulley connected to sucker rod? Because you are reducing speed. So small, let's say diameter ratio D small d, so d by small d, so your speed also will be changing the same way. Big speed n, small speed n, small n, then it will be just opposite. Small speed will be higher. Okay, this way you are changing your speed. If 2 times, then it will be if big wheel diameter or big sieve diameter, let's say 1 meter, small is 10 centimeter, so 10 times speed will be changed. So speed reduction will be 10 times. So if it is 3000 rpm, 3000 motor, then your is sucker rod speed will be 300 if d by d equals 10. Okay, if your diameter ratio is changed to 1/10, it's 10 time, then your speed will be reduced to 1/10. Similarly, if you have gear drive also, your speed will be changing the same way. And when in belt drive, several things are there. If you go through details of the belt drive of V belt, so normally V belt will be carrying higher power, and in PCP system you need very high power. So that's why you'll be using this one. And V belt means belt cross section. If you see one belt is like this, and if I take one cross section will be looking like this. Okay, so several layers of cotton and rubber will be there. Okay, and your pulley is like this. If I take cross sections from side, okay, let's say this is my pulley. Okay, so this will have groove, V type groove will be there. Okay, so pulley from side, if I see, it will look like this. Okay, from top, bottom also will be looking like this. Okay, okay, and belt will be put here. Okay, belt will be here. Okay, so the belt and groove, these are called groove. The groove on the pulley will be such a way that the belt will be fixed properly, so that it will have more surface contact. So if more surface contact is there, that means more friction is there, means whenever high pressure is getting transferred, because of friction, the smaller wheel will be turning the bigger wheel without sliding. If that contact is not there, that surface area contact is small, then it will be sliding. So flat belt, if you see the flat belt, this is flat belt. Okay, this flat belt, this is flat belt. Oh, okay, I have written already. This flat belt will have less surface contact area, so its power carrying capacity will be low. So in very high power transmission case, we do not use flat belt, we use V belt, so that will have more surface contact. Like if you see this picture I am drawing, this area, whole contact area for V belt. Okay, and if you have more tension, this belt will be gripping properly on the grooves of the sheaves or pulleys. Okay, that way it will be transferring more power. So on your PCP surface drive also you are using V belt. Even your sucker rod pump, you can remember SRP or beam pump, there also you are using V belt, transferring power from motor to your gearbox. Polish rod already it is similar to sucker rod pump, but in sucker rod pump one thing was there, it was reciprocating inside your seal section. All right, like Polish rod, and this is seal, right? So seal, let's say this is Polish rod, sealing be properly so that no fluid will be entering and going through this seal. Okay, so seal section called stuffing box. If you do not make polish rod the surface finish properly, then what will happen? This surface unevenness of surfaces, it will be tearing away this seal surface. So finally, after certain operation, it will be leaking. So in sucker rod pump, it was reciprocating, but in this case, it will be rotating. Okay. So this is rotating for PCP, but reciprocating for SRP. Okay. Thrust bearing. Why thrust bearing will be required? So because you have whole long sucker rod and it is hanging from somewhere and rotating also. Okay, hanging and rotating. In sucker rod pump, we do not put any thrust bearing because that nodding donkey or horse head, it was pulling up and down, so there is no thrust bearing there. But in this case, your rod is not moving up and down, rather rod is rotating. Okay, because of rotating, you need one thrust bearing. How the thrust bearing will be working? And let's say one bearing is this. Okay, and okay, and you give rotation to this. This is bearing. Okay, so two rollers are there. let's say this here lots of balls are there, and this is my shaft rotating continuously, and because of load it will go down. So we don't allow to go down. What we'll do, we'll put lots of bearing and some flat plate I'll put here. In between there will be lots of balls. Okay, so balls are there, flat plate is there. So flat plate will be rotating smoothly over the ball, and it will be holding the load also. Okay, although this black one will be pulling down, and this upper plate is fixed here, so it is rotating continuously. It is not allowing to go down because there are lots of balls over there. There is no friction. So this way you create a thrust bearing. Thrust bearing takes load. Okay, which load? Axial load. So thrust bearing is not made for radial load, no radial load. Okay. Okay, so drive head will have all these things like motor, your belt drive, your gear mechanism, so that you can reduce the speed. Then there will be one stuffing box, and one backspin controller also will be there. Okay, if certain because of certain reason your motor is not working, your rotation got stopped, then because whole fluid column will be working on the pump, so pump will be trying to rotate, and that will be disastrous sometime. So you should have one braking system or backspin controller system to stop the pump. Okay, so that is called backspin controller. Okay, whenever we are talking about sucker rod will have their own table for sizing. So nominal diameter of sucker rod for weight, to get weight of the sucker rod you have to get nominal diameter. So like for example 3 by 4 inch size sucker rod, it will have nominal diameter 19 millimeter and weight in air 2.37 kg weight in air. Okay, so if you have larger diameter sucker rod, for example 7 by 8 inch, then your weight will be 3.17. If you have 1 inch, then your weight will be 4.20 kg per meter in air. If you have 1 by 1/8 inch, so your weight will be 5.36 inch. So if you know your rod size, accordingly you can calculate how much weight will be there on your thrust bearing. So thrust generated by the head rating pump. So the formula I already given to you, pi del p 2e plus d whole square divided by 4. This is the formula I have given already in the last lecture. Okay. Total stress on the driving system. Total stress on the driving system, F equals F plus FB, FP plus FB. Okay, axial. Okay, so total stress is coming because of fluid load and its own weight. This is own weight. This is fluid load, and so because of that you are getting stress. Stress is equals 0.4 divided by pi d cube f square d square plus 64 t tau square into 10 power 6. Okay, so this is stress in MPa. Total stress. D is the diameter of driving string, dia of driving string or sucker rod. Tau is the resistance torque. Sigma t in MPa. Okay, now there are two types of rod grade will be there, C type and D type. Okay, in API table you can find the C type grade. Minimum MPa, minimum and maximum load will be there. Minimum is 620 minimum MPa and will be max megapascal, maximum megapascal 793 and 793 here 93 and maximum is 965. Okay. Okay, so tubing, because sucker rod is long rod, and when you are using sucker rod and it's moving through the tubing, so there is possibility that rod can be bent or there will be some slantness. So in that case you have to put some centralizer. Okay, so centralizer is like this. So some mechanical equipment such a way that it will allow rotation, but it will not allow to touch the tubing. So it will be all around some mechanical arrangement, so that whenever it is rotating, it will be rotating inside the tubing centralized. Okay, that's why name is called centralizer. Okay. So if a vertical well is there, so only 4-5 centralizer will be okay. But if crooked well bore is there, then you have to put several centralizer. Otherwise, this rod or sucker rod string will be touching the tubing, and when it is touching the tubing will be getting constantly eroded because of the rotation. It will friction will be there, and tubing can be leaked or sucker rod can fail. Even it can reduce vibration also. And another function of centralizer can be there, like tubing outside also you can put centralizer, so the tubing when it is bending it should not touch the casing. Okay, so centralizer will be centralizing the system so that the vibration can be avoided and it will not touch the tubing or it will not create any rubbing action. Okay, so that life can be extended. ESP-CP, we discussed already. ESP, you can remember in other lectures, just you see the 2 lectures, several lectures will be there on ESP. So electric submersible pump, in this case we use centrifugal pump. Okay, but whenever you are talking about ESP-CP, we use PCP, ES plus PCP, electric submersible, because ESP term already the centrifugal pump they have taken, so we cannot use the same term for PCP. So the designers they put ESPC, electric submersible PCP. Okay, so as it is in ESP, you will have one motor, induction motor, squirrel cage, induction motor. There will be one protector. So electric cable is coming here, motor is here, protector must be there. Then there will be pump. Okay, and your cable is coming directly to motor. Okay, so motor will be giving shaft power and shaft will be passing through your protector, then your intake section will be there, intake section to your pump section. The similar way, instead of centrifugal pump you are putting PCP. Okay, multi-stage PCP. So one rotor, I already told that one stator pitch length is one stage, so multiple stage means multiple pitch length. Okay, so it will be also several meter long progressive cavity pump to deliver viscous fluid or high viscosity or heavy oil. And surface unit also will be same, like you will have gas venting, you will have your VFD system, you will have controlling system, all the system are same, only the motor inside there. And one more thing will be there, if motor speed is higher, then you have to use one gear drive to reduce the speed. Normally this induction motor, for induction motor you are using 4 pole or 6 pole. So when you are using 4 pole or 6 pole, your speed will be 300 or for 50 hertz. So better I will write like this: 4 pole 6 pole. Okay, and hertz 50 hertz, then speed is 300, this is 200, it is 60 hertz, then speed will be 360, 240, and motor is producing higher, but in between motor and your pump there is one gearbox system. Gear normally 1:5 or 1:10, that ratio it is reducing speed. So that's why finally you are getting that this much of speed, okay, using the motor.